Hello all, this is Dr. A. Anuja, Assistant Professor, Department of Mathematics, Arulmigu Palaniyandavar Arts College for Women, Palani. In this lecture, we are going to discuss about one theorem. The name is Three Coplanar Forces. The statement of the theorem is, if three coplanar forces acting on a rigid body keep it in equilibrium, so they must be either be concurrent or be all parallel. So the concurrent means they intersect at exactly at one point. So the proof, let P, Q or be three coplanar forces which are acting on a body and keep it in a equilibrium. So the body will be in a rest. So then R must be equal and opposite to the resultant of P and Q. Now P and Q being the coplanar must either be parallel or intersect, which means the forces P and Q be parallel, or otherwise P and Q or B must be in intersect. So we are splitting into the two cases. In case 1, we'll take the two forces are in parallel. In case 2, we are taking into the two forces are intersect at one point. Now we are going to discuss about the parallel case, which represent in the case 1. If P and Q are parallel, which means the parallel forces are like or unlike any, their resultant is also parallel force. As R represent the resultant, as R balances the above resultant, it must act in the same line but in opposite directions. So R is also in the same directions as of the P and Q. So if P and Q forces acting in some directions, the resultant is also acting in the same directions of the forces P and Q. So therefore, the three forces P, Q are all parallel to one another. In case 2, let P and Q meet at a point O, then by parallelogram law, the resultant is a force through O. As this balanced by the third force R, the line of action of R must also pass through O. So therefore, the three forces are congruent. So hence proved. The important note, in the above discussions, we are considering the two forces, that P and Q, can never form a couple, since we know that the couple and a force can never be in an equilibrium. So that is the important note for the theorem. The next one, another theorem. The statement of the theorem is, if any number of forces acting on a rigid body be represented in magnitude, directions and line of actions by the sides of polygon and taken in order, they are equivalent to a couple whose momentum is twice the area of the polygon. So the proof, we are considered the forces. So these are the sides of the polygon. So the polygon name is A, B, C, D, E, F. So those sides are A, B, B, C, C, D, D, E, F and F, A. So these are the sides of the polygon A, B, C, D, E, F. Now we join AC, AD and AE, so which are given in the figure. So we'll have one closed polygon. We are joining the diagonals AD and A to D and A to C and A to E. So the figure is given in figure 9. Now we introduce along AC, AD, AE. So these are pairs of equal and opposite forces represented completely by these lines. So now these new forces do not affect the resultant of the system. So we are introducing the new forces. Those are AC, AD, AE. If we introduce these three new forces, these forces do not affect the resultant system. So now we are applying the law. We have AB vector plus BC vector plus CA vector. So we are adding these forces. So we'll get a couple whose momentum is equal to twice the triangle ABC. So we see this, it will form a one closed triangle. So AB vector plus BC vector plus CA vector, it is equal to a couple whose momentum is equal to twice the triangular of ABC. Similarly, we are applying the remaining three cases, AC vector, CD vector plus DA vector. This is also forming a one triangle. So this name is ACD, which is a couple whose momentum is equal to twice the triangle ACD. And AD vector plus DE vector plus EA vector equal to a couple whose momentum is equal to twice the triangle ADE. The next one, AE vector plus EF vector plus FA vector equal to a couple whose momentum is equal to twice the triangle AEF. Now we adding these four cases, so we'll get the left hand side AB vector plus BC vector plus CD vector plus DE vector plus EF vector plus FA vector. So this is equal to resultant of the four couples. So from these four cases, these resultant give a one single couple, whose momentum is equal to, we are adding these four twice triangles. So we take a 2 as a common, and triangle ABC plus triangle ACD plus triangle ADE plus triangle AEF. So therefore the resultant is couple whose momentum is equal to twice the area of the polygon of ABCDEF. So hence bro, thank you.